Hello. In this video, we'll discuss the basic logical programming with C, the printing of different patterns, and how the logical modelings are done for printing the patterns for different patterns in C. Let's take an example of printing a pattern of A alphabet. So now, what we have, the A pattern, which we want to print with the help of a C program. First of all, how to model the problem logically. Suppose, for example, there are n number of terms. There are n number of terms. In this case, n number of terms means n number of rows we have. In this case, we have a value of n as 5. The value of n is 5 because there are 5 rows in this particular structure. So this is applicable for any number of rows. We can change the size by changing the number of rows or number of terms. The basic structure, to print the basic structure, we assume the number of terms is 5, the n equal to 5. For here in this particular observation, we plot in a table the number of points in the particular triangle. So this is a pyramid. Number of points in a particular pyramid or particular triangle. So in this pyramid, for first row, how many points are there in the pyramid? Only 1 point we have. That prints a star. And how many points as blank? In the first row, we have 1, 2, 3. 1, 2, 3, 4 blanks we have. Now for second line, we have the number of points. The number of points in the pyramid, we have 1, 2, and 3, where 2 stars are printed, and in between there is 1 blank. So 3 points are there in that particular triangle. And how many points are there in the blank? How many blank portions are printed in the second row? 1, 2, 3. 3 blank positions are printed. 3 blanks are printed. So 3 spaces are printed. So there will be 3. So just we plot accordingly. Third line, we have when I equal to 3, we have the number of points here as 5 and number of blanks as 2. In this way, for fourth line, we have the number of blanks as 7 and this is 1. For fifth line, the last line here in this example, we have the number of points in that pyramid 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 points we have in the triangle, where only 2 stars are printed and remaining 7 in between places are blank. So we have how many points, in how many spaces are left? No space, 0 in the particular last row. So what we can see, the number of points in the particular triangle is an increasing function of I, is a positive linear function of I. So what we have, it is a positive linear function of I. So we have I is 1, the number of points in the triangle is 1, I is 2, it is 3, I is 3, the number of points in the triangle is 5, I is 4, it is 7, for I is 5, it's 9. So it's a positive linear function of I. So what we have to see we have to test with different alternatives. We can find 2 2s are 4, minus 1, 3. 2 1s are 2, minus 1 is 1. 2 3s are 6, minus 1 is 5. So generally we can say the number of points in the particular triangle should be 2 into I minus 1 equal to 2 into I minus 1. So the number of points in the triangle where either stars printed or the blanks, there will be blanks or spaces. Now in case of the number of blanks before the particular triangle, before the particular pyramid, the number of blanks is a decreasing function of I. As I increases, the number of blank decreases. So it's a decreasing or negative function of I. The number of blanks is a negative function of I. So we can say minus I. And as n goes, if n is higher, the number of blank in a certain line will be higher. If n is 5, the number of blank is 4. When n is 6 in the first line, the number of blanks would be 5. If n would be 7 in the first line, the number of blank would be 6. So it is a positive function of n. So we can say n. And let's take, it's a linear function of n minus I. Let's take 5 minus 1 is 4, 5 minus 2 is 3. Oh, it's exactly equal to n minus I. It is exactly equal to n minus I. So number of blanks for a certain I will be n minus I. For a certain row, for a given row, the number of blanks will be n minus I. And number of points in a particular, in the triangle will be 2 into I minus 1. Here. Now inside that, where the stars are printed and where the blank is left. Now see, in case of the triangle, inside the triangle, what we have, inside the triangle, what we have, the stars are printed when for the first instance and the last instance. First instance and the last instance. And also when the row number is the median of the total number of terms. If I is a counter, if we use I as a counter representing the row and J is a counter representing the column, so the J counter for this pyramidal structure, the J counter for this triangle, for the J counter of this triangle representing this particular triangle, when J equal to 1 or J equal to the last terminal value 2i minus 1, there will be star. So if I represent by J, either J equal to 1 or J equal to 2 into I minus 1, there will be star. Now, not only that, or when I is equal to mid value of n, median value of n plus 1 by 2 means 3. When I equal to n plus 1 by 2, the mid position, 1 divided by 2. So in these three cases, either j equal to 1 or j equal to 2i minus 1 or I equal to n plus 1 by 2, the median position of n. So the star will be printed, printing star, print star, otherwise print blank, otherwise blank, print space. How to represent in a program? So first of all, we have the I loop, we have the loop for I, for loop or while loop or do I, any pattern of loop we can use. A loop having the I as a counter that represents the rows, and J counter represents the columns for blanks, the columns for the pyramid. The two J loops we can have, the two sub loops, two nested loops we can have, where J can be the counter. That the first nested loop, the J counter will represent the blanks. In the second sub loop, a second nested loop, the J counter may represent the star or in between blanks. Okay. So first of all, let's start the program. The variables we have, digit n, I, j. But n is the number of terms. So printf, we have enter the number of terms, scanf %d ampersand n. Now we have to start the check the row counter. I should be 1, I less than equal to n, I plus plus. It will go start from the first line, it will go to the next line. For every I, for every row, I represents a row. I is a row counter, I is a row index, where j represents a row, But for J should be starting with 1, as we have the number of blanks will be printed prior to the number of stars or the pyramidal structure. Before the pyramidal structure, before this particular structure where we have this A, there will be blanks printed. Otherwise, we can't get the structure of A, structure of pyramid. So first of all, blanks will be printed. So for blank, we have n minus I. So J loop will start from 1, the column counter for printing the blanks. J less than equal to n minus I. J plus plus. What we have? Printf. After that we can have for printing the blanks. The next loop that will print the pyramidal structure, that will represent the printing of the triangular or pyramidal structure, that is 2 into I minus 1, 2 into I minus 1. Now it is conditional. Where the stars will be printed? If it is under the condition, under the pyramidal structure, the printing of star will be conditional. The printing of star is conditional. If J equal to 1 or J is equal to its comparison operator. J is equal to terminal value 2I minus 1 or I is equal to n plus 1 by 2. By 2. Either J equal to 1 or J equal to 2I minus 1 or I equal to n plus 1 by 2. Any of these conditions, if satisfied, then the star will be printed. Star will be printed if any one of these conditions are true. Any one of these conditions is true. If any one of these conditions or any two of these conditions or all of these conditions or any combination of these conditions are true, then a star will be printed. Otherwise, failing which, if none of the conditions are satisfied, then we have, again, the blanks will be printed. Again, we have the blanks will be printed. Here, the blanks will be printed. So we have this. This is under the nested loop J. So we have this particular nested loop for printing the pyramidal structure. This is a nested loop for printing the initial blanks in the left side. And this is the inside the pyramidal structure. We represent by the J loop, the J index 1 to 2I minus 1, in which the printing of star is conditional. Satisfying any of this condition will make the star be printed, and if failing which, the blank will be printed. So we have the next line. After every row, we can have this. So this is the way we can represent the thing. Let's check some syntax problems or not. Is there any syntax error or not? Enter the number of terms. No, we are running it. We can print the A. See, the structure of A is printed. Now we can make it bigger, enlarged. We can choose any number of terms for any value of n. It is applicable. It is any value of n, it is applicable. The A is printed just like this. So likewise, any structure we can print B, C, D, E, any structure or any pyramid, diamond or stars or any structure we can print by using the same logic that is actually based on the linear algebraic concepts. And it's very preliminary and very basic in developing the programming skill and the logical skill and the connection between the linear algebra and its principles with the programming, the loops, the iterations, and the structures. Thank you. Thanks a lot.